Okay, we ready?
We're ready.
Okay, so what we're going to talk about today is the mid-tier product that came out the beginning of 2024 when they changed all the testing requirements so that as we test equipment for efficiencies, they changed all of the standards on us. So we had to retest, and in some cases we retested equipment, and that changed the efficiency. In other cases, we made new equipment. We redesigned the equipment. So we're going to primarily focus on what we redesigned today as far as mid-efficiency air conditioning, mid-efficiency heat pumps, and a couple things on gas furnaces that have changed. So as we go through it, if you have questions, please ask them. I'm pretty upfront, and I'll just, if you've got a question, I'll tell you what I know. So, looking at the equipment, what we're going to be focusing on is the 15 and 16 SEER air conditioning. Those are new for us. They're inverter driven, and they use a twin rotary compressor. Okay, so it's like a mini split compressor that are in these things. So it's inverter driven. It's a 230 volt single phase compressor, and we change the cycle rate to change the speed of the compressor. And then the 16 SEER heat pump is also a twin rotary compressor, so it's inverter driven. The 15 SEER heat pump, which is just come out, will be a two-step scroll. And this is just kind of a model explanation of the model number. I'm not going to go through every product, but the first letter gives you the brand, and from 15 SEER down, whether it's REAM or RUUD, it's R. When you get into the premier product, like the 16 SEER and the 18 SEER, it'll be a U for RUUD. And then P is a heat pump, A is air conditioning. We give you the SEER. We tell you what region it can be used in. Up here, it's not that difficult because you guys can still install 13 SEER. You know, in most of my territory, that is the case. You can install 13 SEER air conditioning. But down in Cincinnati, we have to make a point of it, because if you go over the border into Kentucky, their minimum SEER on air conditioning is 14, so they can't have it. It'll be A. If it's an A, it means it can be installed anywhere in the United States, all regions. N is North region. Okay, up here, that doesn't mean anything to you guys. If the inspectors down there see an N, they will red flag the job. And then the refrigerant, the Z. Everything right now is 410, but in 2025, we're going to be changing to R454B. Okay, so it's more environmentally friendly. You got to have the buzzwords, right? So most manufacturers are going to 454B with the exception of Daikin. They are going with R32, and that's because they own R32. They make it. So that's their own refrigerant. And then a lot of the mini split manufacturers are going to be with R32. But like us, Trane, Carrier, Lennox, primarily are all going to R454B. Slightly more flammable than 410A, but still not anything crazy. I mean, you know, when they first started talking about changing refrigerant, they were talking about butane and propane and all. This is nowhere near that. I mean, you've got to expose it to direct flame in order for it to burn. And then we give you the capacity. And all of the inverter units and multi-stage units are even tonnages. There's no half tonnages on that. It's the single speed units that have the half tonnages. And speaking of that, and then we have A is a major series change. J is voltage, basically for residential. Everything's 230 single phase. The type, whether it's a single stage unit, two-stage unit, or three-stage unit, or in some cases, when you get to 18, it'll be an M for a modulating unit. That one is full modulation from 40 to 100% up and down. And then what type of controls, whether it's communicating or non-communicating. And then the last letter is any minor changes that we might make on it, like if we change a motor or something. Okay, on the gas furnace size, the Classic Plus, the 962 and the 802s are what we really call the mid-tier. And the difference in that is a couple differences is we changed the blower motor from an ECM motor to a constant torque motor with a PWM signal. So they call it a constant CFM motor. Okay, the control board will give it a signal and tell it how much torque it needs to exert, and then the motor comes back and tells the board how many RPMs it's turning. Okay, so it's a fully communicating motor, and it's a true constant CFM motor. We also changed the board on this furnace. Okay, we always in the past have bought our boards from UTEC, Honeywell, Emerson, or White Rogers, and now we have a company that they're not in the HVAC business. They just build electronics. Same people that build our Econet control. They're building the furnace boards for us now, and the air conditioning boards and the air handler boards. These are actually what we call RUUD manufactured boards. Okay, you can't, they're built specifically for us. And when we did that, in previous generations, we would not share the full Econet protocol, communication protocol, with Honeywell or White Rogers or any of those folks, because we had an experience years ago when we helped design CC2. That was our first communicating system on our old equipment. And Emerson, we helped Emerson design it. They promised they would not sell it to anyone else, and they kept their word, but they changed one thing on it and sold it to Goodman. So we were very cautious about allowing anybody that was in the HVAC industry to have access to the Econet protocol. So the result of this is we now have single stage furnaces that have variable speed motors on them, and they have full Econet capability. So you can get a 92% furnace with a variable speed motor and have Econet. And that'll become important later on when we start talking about how to wire up these things. We also still have the 98 and the 97%, which is the modulating furnace. It'll modulate from 40 to 100%. That hasn't been redesigned yet, but it is in the process of it. It uses an ECM motor and still uses a Honeywell board.
They still gonna be multi-position.
Pardon?
Are these ones multi-position too?
The 96s and below, the 90s are all four-way multi-poise. The 98 is upflow only. The 97 is downflow horizontal. Okay, and it's horizontal left or right. And so I don't know if they're going to try to make the 98 four-way multi-poise or not, but And the 80% furnaces, you'll have some that are upflow horizontal right, and the others are downflow horizontal left. Okay, so you'll have a true upflow and downflow, and they're horizontal one way or the other. And this breakdown of the furnaces, okay, gives you the brand, the input, how many stages, whether it's single stage, two stage, or modulating, type of motor, where it's constant torque or an ECM, variable speed, the heating input, the air conditioning capacity, and all of ours are either going to be 3-ton or 5-ton. Then any major design changes, the cabinet width, okay, and we'll make a 14, 17, 21, and 24 inch. The 14 is only on one furnace. That's on the 50,000 BTU, 80% furnace. The only one's 14 inches wide. Everything else is 17 inches or bigger. And then the position, it'll tell you in the model number. If it's M4, it's a multi-position. If it's UP, it's upflow. DZ is downflow. Zero clearance. UH is upflow horizontal. And DH is downflow horizontal. So the model number tells you what positions that'll go into. Most of the 90s, 90 plus, the 92s, 95s, and 96s are all four-way multi. And then we have whether it's a standard burner, a low NOx, or an ultra low NOx. The only place that uses low NOx right now is California. Okay, we build that especially for the land of fruits and nuts. So, and they've been using low NOx for, I don't know, 10, 15 years, and it hasn't spread. So that's a good thing. Then we have the type of controls, whether it's communicating with Econet and Bluetooth, or communicating with Econet only, or non-communicating, any minor changes, any option codes that you may add on it. And I don't even know that there are option codes right now. When we first started making 90 plus furnaces, this series of 90 plus furnace in 2013, they would ship the furnaces up here with no bottoms in them. Didn't have a bottom included with it. You had to order the bottom as a separate part, okay? Because down south, everything is bottom return. They didn't understand basements. Okay, and we use basements and we need side return. So that's why now the top is shipped, the bottom is shipped on the top. The side benefit is it made it more rigid, and we get a lot less shipping damage with that bottom screwed in on the top. So we had to change the coils to get the efficiency. The only difference between this coil and the old coil, like this is a 25, for example, RCF 3717, it's the same coil as the RCF, or this is the RCF Z 3717. It's the same coil as the RCF 3617, but the TXV is different.
Mounted on the inside already?
No, it's mounted. Yeah, it's already mounted and everything, just the same as it was. It's just a different expansion valve. What's that?
Now when you buy them, you gotta mount them.
You're gonna mount the bulb.
Yeah.
Yeah, you still do.
So you don't have to do it these.
Yeah, you still have to mount the bulb, but it's a different TXV that gave us a little more efficiency, so that we could get that 15 and 16 SEER. Okay, So if you are registered, or if you're going to install one of these and you're going to register it for the 10-year warranty, you have to have, it has to be an AHRI matched system. You have to use one of those coils with the new outdoor units. If you try to use one of the old coils, it won't allow you to register it. Okay? It doesn't ask you, and this is off topic a little bit, when you're registering them now, it does not ask you for the coil model number. You can register just the outdoor unit and the indoor and the gas furnace. What it does do at the end of the registration is it will ask you if it is an AHRI matched system, and you have to check a box saying yes it is. Okay, that was done so that if you have a system and you want to use an ADP coil or an Aspen coil, and those are the two brands that are approved, they have if you look it up and you find our outdoor unit with a ADP coil or an Aspen coil on our gas furnace, you can register it. We never used to let you register it unless it was completely a RUUD system. You can now register just the outdoor unit and the furnace. But as long as it's matched with an AHRI rated ADP or Aspen coil, that's okay. If you're, and again, this is something they don't understand down south, we take coils and mount them in plenums. They don't do that. Okay? They use air handlers or they use case coils. So if an ADP coil works better for you now, go ahead. We're not going to cover the coil if something goes wrong, but we're still going to cover the outdoor unit or the gas furnace. And this is just a breakdown of the coil part model number. We have a new air handler. This is the RH3VZ. Okay, this is a 3-speed air handler, and it's used primarily with the 15 and 16 SEER air conditioning and the 16 SEER heat pumps, because those are 3-step inverters, 3 speeds. And that was one of the issues that we had with the 17 SEER, the old one. If you wired the old 17 SEER up with an Econet, it would modulate, as it stepped the compressor speed up from low to intermediate to high, it would communicate to the gas furnace, and it would speed the blower up to match the capacity of the pump. If you put a 24-volt thermostat on that, you had Y1 and Y2. So the way it worked is you get a call for Y1. It ran for 10 minutes on low speed. 10 minutes later, it went to intermediate speed. And then when Y2 made, it went to high speed. Gas furnace only had Y1 and Y2. So you only had 2 blower speeds. When you went to intermediate speed on the compressor, the blower stayed in low. Okay, on the new one, with this 3 speeds, the blower speed will change with the compressor speed so that you always have the correct airflow. And this is a breakdown of the air handler model numbers. So the 16 will either be an R or U. R is REAM, U is RUUD. The 15 will be an R, that's REAM or RUUD. It matches up to, and there is a difference, This will match up to that RH3V air handler, an 802V, which is a two-stage 80% furnace with variable speed motor. The 962 furnace, which is a 96% efficient furnace, two-stage with variable speed. The 97 or 98 modulating furnaces. And it will use an Econet or a 24-volt thermostat to control it. The 15 will use the 3V, but it's also matched with an 801V. The 802V, the 951, the 921V, the 962V, the 97 and 98s, okay? So when you get into the 921 and 951, that's a 92% furnace and the 95%. We make two of each. We make a 92%er that has a variable speed blower motor, okay? We make a 92%er like we've always built, the old one, that had the constant torque motor in it. And it still has the old board in it that has the 7-segment LED and the dip switches. And we do the same thing with the 95. We make a 95 that's got a variable speed motor in it. And we make a 95 that just has a constant torque. One of them you set up using Bluetooth. The other one you set up using dip switches. The T models are what we consider our builder model. They're for new construction and apartments and whatever, okay? The V models are more the upgraded, it's got more bennies in it, more goodies in it than the T's. And then we have the 16s here. It'll match up with the 3-stage air handler, the 802V furnace, the 962, the 97 and 98, and he can use either Econet or a 2-stage heat-cool thermostat, and that'll make it a 3-stage unit. So when we get into the outdoor components, we're going to talk a little bit about the outdoor control boards, the contactor, which is different than, you know, most of our units have a single pole contactor in them. This is a special contactor that's used on these mid-tier inverters. Okay. We'll talk about the compressors because they're going to be a little different. They're a twin rotary. We talk about the outdoor fan motor, which on high efficiency, this is kind of a big deal because on some of the high efficiency, we use the ECM motor. So you had the module on it and you had a big heavy motor hanging from the grill. Well, on all this new equipment, we did away, especially on the motors, we did away with that module and we went to a constant torque motor with PWM feeding it. All of the programming for the motor is no longer in the motor. It's on the board. Okay, so you don't have to have that ECM motor with the big module on it anymore. Okay, when you change the motor, you're going to have to use the Bluetooth app because you're going to have to download the program for the motor, and then you're going to have to upload it to the new one. Okay, the way it is right now, if you need a motor, an ECM motor, you have to come to 2J Supply and get that motor and hope that they, you know, I mean, there's so many SKUs of ECM motors, so many different ones, and you can't interchange them. They don't intermix. So we'll talk about the outdoor fan motors, the reversing valve, pressure relief valve, and what it does, and the outdoor coils. They changed. So this is what the control panel looks like. Okay, if you were familiar with the old inverter units, we had 3 boards in it. We had an inverter board up at the top Then we had a filter board, and then down the bottom we had a VSODU, which was the variable speed outdoor unit control board. And that VSODU had a little EEPROM card that was plugged into it, whether it was the outdoor variable speed outdoor unit or if it was a gas furnace. They all had this little EEPROM card that plugged into it that kept all of the program information, and when you changed the board, you had to make sure you kept the card. So now you've got a MODBUS connection, and all the MODBUS connection is a communication link that goes from the inverter board to the UODC with control board. Okay, the universal control board. The thermostat or the Econet tells the universal control board what we need it to do. And then the universal control board tells the inverter what it needs to do. Tells it if it needs to speed up, slow down, whatever. It does it through that MODBUS connection. Then that's the inverter drive board. We have a ferrite ring on it. That's the only thing that we use for filtering the voltage coming in, try to clean it up. We don't have anybody here from Kentucky, so I don't think you drove that far. Kentucky's got some god-awful voltage. It fluctuates all over the place. I mean, there's protections on this compressor so that if the voltage gets too low, it locks out. If it gets too high, it locks out. Because this is a $3,000 compressor. Okay, there's all kinds of protection on it. And in some places that I've been on in Kentucky, it can be tripped off on high voltage in the morning and tripped off on low voltage in the afternoon, or high voltage in the afternoon. It just is all over the place. We have contactor, capacitor, and the universal outdoor control board. That is the brains of the outfit, okay? And all of the safeties, pressure switches, everything connect to that except for the high pressure switch. That connects to that, but it also connects directly to the inverter board because we're required by agency, the testing agency, to hook it directly to the inverter board. So if it goes off on high pressure at 610 pounds, it immediately will shut the unit down. It doesn't have to go through the communication link from the UODC board to the inverter board. They wanted it hooked directly to that inverter board. So this is just a close-up of the actual inverter. There's your MODBUS connection up there at the top. There's the terminal where the high pressure switch connects. We have a relay coil connection. Power input, that's where the 230 volt is going to go into the inverter. And then your compressor output down here at the bottom, that's where the changed voltage or cycle rate is going to go through here to the compressor. And then you have your fan output, and that's where your PWM signal is going to come out to go to the fan to operate it. This compressor on the previous generation inverter units, that was a 3-phase scroll compressor. And they took AC voltage, put it into the inverter board, changed it to DC, and then changed it back to a simulated AC signal that went to the compressor to tell it how fast to turn. Okay, the mid-tier stuff is just a 230 single-phase compressor, and all we're doing is changing the cycle rate from 60 to 50 to 40. That's all we're doing. We didn't have to change it from AC to DC to a simulated AC cycle cycle rate or anything. We're just changing the AC cycle rate. Compressor is fed with 230-volt single phase power. This is just showing a close-up of the high pressure connection. It opens at 610 pounds. It will reset at 490 pounds. It's only considered when the compressor is in operation. This is the back of that inverter board. There has like a cast aluminum heat sink on it. And that sticks into the airstream where the fan is. So that when the fan is running, it's pulling air across it just like it would a coil. Okay, if you're cleaning the coil, and that can get dirty. It can get cottonwood, it can get all that kind of stuff in it. Don't clean it with coil cleaner. It's okay if you want to shut the power down and just spray it out with water and wash all the gunk out of it, but don't use any chemicals on it. And this UODC, this is the universal control board. There has a test button on it, so you can bump the unit to see if it'll start. It's got the MODBUS connection. This is the other end of that cable that goes from the UODC over to the inverter board. Pressure relief valve, okay? And we'll talk a little more in detail, but basically that pressure relief valve is just a solenoid that when the unit shuts down, that solenoid opens and equalizes the pressure in the system. This twin rotary compressor will not start if you got more than a 20-pound differential between high side and low side. So we have to equalize the pressures. We have a ground terminal. There's where the other end of the high pressure control hooks. So high pressure control connects to this UODC, one side of it, leaves here, goes to the high pressure control, goes through the high pressure control to the inverter board. Reversing valve down here at the bottom. Thermostat connections and Econet connections on the bottom. And that plug is just like the furnace plugs now. You can pull it right off. It's got the terminals designation printed right on it so that you don't have to keep looking and miswiring, all the low voltage connections. You have a liquid transducer, suction transducer, liquid temperature sensor, suction and coil temperature sensors, outdoor temperature sensor, discharge temperature sensor, and a Bluetooth transmitter. That's your antenna up there. Okay, as long as that antenna is in place, you should be able to make a Bluetooth connection if you're within 10 feet of the product. Okay, and that's a close-up of the terminal block. Shows all the thermostat connections. You got E1 and E2, R and C, which you will use a lot. Occasionally you will use Y. You should never use Y2 or B, W, and you may use U2 and U, and I'll explain what those are for later. Okay, differences on these boards. There's no 7-segment LEDs anymore. Those are gone. There's no dip switches. Okay, a prime example of why is the old 96% efficient furnace had 18 dip switches. If we were to have continued using dip switches, there would have been something like 28 different dip switches on this board to make the adjustments. So that's why you now have Bluetooth. And since you have Bluetooth or Econet, there was no need to have the 7-segment LED or the dual 7-segment LED on the board. say, if the UODC is changed, you have to take the old program off the old board and reload it on the new one, because the new board is naked. There's nothing on it. And then basically all of the sensors are the same as the older units. On the outdoor units, universal outdoor control boards, there are 3 LED lights. There's a green light that's marked BLE, that's the Bluetooth light. If it's flashing, it tells you that Bluetooth is working, it's available, and you can connect to it. If it's solid, it means if you have somebody working with you and you both have the app, it may have connected to your buddy's phone. Okay, so when you are working on it, you want to make sure that you only got one phone that's going to connect to it. The second light is the cooling light. It's kind of a green, and it gives you 1 blink for every 10% of capacity. So if it has Econet on it, 4 blinks is 40%, 7 blinks is 70%, 10 blinks is 100%. That easy. Tells you what capacity the compressor is running at. If you're in heating mode, the amber light is the one that will flash. Does the same thing as cooling. 4 blinks is 40%, 7 blinks is 70%, 10 blinks is 100%. But you're in heating mode. Okay? If you're in defrost, you can tell by looking at it, because the yellow light or amber light and green light are going to rotate back and forth, telling you the system's in defrost. This is the MODBUS cable that goes from the universal outdoor control board over to the inverter board. Okay, so if you're going to look at this and measure it, if you look at on the UODC end, pin 1 to ground should have 18 volts on it, 18 volts DC. That tells you that you're communicating from the control board over to the inverter. Pin 3 should have 18 volts to ground. And if it does, it tells you that the inverter is communicating back to the board. Okay, it's a two-way communication. So you're just checking to make sure that the system is communicating. If you have communication going from the UODC to the inverter, but you don't have a communication from the inverter back to the UODC, you either have a bad cable or a bad inverter. Contactor is different. We generally use a single pole contactor. How many of you guys are service techs? How many of service techs how many of you have ever taken a screwdriver and pushed the plunger in on a contactor to see if the unit would run? Huh? That's what's wrong with you. You use your finger. Okay. Now we know. Okay. So you'll notice this contactor is a 2-pole. It has a cover on it. Don't use your finger. Don't even use a screwdriver. Don't take the cover off. If you manually engage that contactor and push it in, you will let all of the factory installed smoke out of the inverter board. The inverter board When it's running at 40%, it's going to change the cycle rate. When it goes to 70%, it's going to raise the cycle rate a little bit, but it's not going to be at 60 cycles. Okay, when it goes to 100%, that inverter board has to synchronize with the incoming voltage to 60 cycles. And then the contactor closes because the power still goes through the inverter board to the compressor. Well, if you manually push that contactor in before this thing has synchronized, that board is synchronized to 60 cycles, you're going to burn the board up, the inverter board up. Okay, so therefore, that's why there is a cover on that contactor. Now, I know somebody that isn't here today, that should be here today, is going to remove that cover and push that in. It's going to happen. But that's why there's a 2-pole contactor with a cover over the plunger and stuff, so you have to work at it to push it in. This is the highly twin rotary compressor. Okay, it's used by a lot of different manufacturers. Highly is owned by Hitachi. Okay, so a lot of mini split manufacturers use their compressors. It comes with an accumulator on it. If you look at the bottom, there's 2 return tubes off the accumulator that go into the compressors. And that's true on the 3, 4, and 5 ton unit. The 2 ton only has a single tube. It is a 208, 230 volt compressor. It'll operate at 208, 230 plus or minus 10%. Pretty standard stuff for electric motors. Single phase, 60 cycle compressor. They're not blue, they're actually black. This is just a fancy cutaway to show the interior. It still has a rotor and a stator. The discharge tube is at the top. Has the crankshaft, an accumulator, and an upper and lower suction port. So this is what the accumulator that comes with it looks like. It's got a filter screen on it, keep any debris or anything like that from getting back into the suction ports and getting back into the compressor. It has oil return holes so that we make sure the oil gets back into the compressor. It's got 2 suction outlets, except for the 2 ton, that's only a single outlet. It has a spherical cover that goes over those tubes also to make sure no liquid drops down into those suction tubes and goes back. We only want vapor going back to the compressor. And then we have the suction inlet. Okay, so from that suction inlet, we are installing another accumulator in this unit. We put our own accumulator in it as well as the factory accumulator. So it has 2 accumulators in this system. This is the internal. That's it. Got the rotors, what they call the rollers or rotors, and it shows the cylinders. Got an upper and a lower cylinder and an upper and lower rotor. If you look in the center, that's kind of how it works. It's just like an egg shape, and it just squeezes the refrigerant around the cylinder wall and compresses it and pushes it out. It's kind of like a scroll compressor, but it's just got one circle. It doesn't have all of those different scrolls. Big benefit is they're extremely quiet. Even running at 100%, they're very quiet. This is the brushless DC motor for the fan. You'll notice there is no module on it, so it reduces the weight of the motor that's hanging off that grill. Okay. It's a 3-phase motor powered by the inverter. The fan RPM is determined by the frequency delivered. So whether it's 60 cycle or 50 cycle or whatever, it gives you true variable speed capacity or capability. It's quieter because it's not running at 100% all the time. It is more reliable because all of the electronics for that motor are inside the unit. They're not out in the weather. And it's lighter than the PSC or an ECM motor. So you've got less weight hanging off that grill. So one of the important part is the RPM is determined by the frequency delivered. It's important that as the compressor speed changes, you want the outdoor fan motor speed to change so that you're pulling the right amount of air across the coil and you get the right subcooling. The other part of that, and we'll talk about it in a little bit, is that you want the indoor blower to run at the right airflow so that it matches what the compressor is doing. You want all of these things communicating so that all of the fans are running together, all of it with the compressor, and you've got the right outdoor airflow and the right indoor airflow. That is the pressure relief valve that I was talking about. It's just a simple solenoid. Okay, during an off cycle, it will open so that the pressures can equalize, because this compressor won't start against high head pressure. If it's got more than 20 pound pressure differential, the compressor will not start.
What's the delay on that?
What's that?
How long is the delay on the relief?
What's the delay?
How long?
No more than 5 minutes. That's kind of a schematic of the piping. That's an actual picture of the unit inside. So you can see there's your compressor and the factory accumulator. Up there in the top with the square box, that's your pressure relief valve. Down here in the bottom right, that's the extra accumulator that we add. Then you have a muffler. Actually, that's looks like a charge compensator. Service valves, outdoor expansion valve. The coils are different. They changed them. They went to a 7, instead of 3/8 diameter tubing, it's 7 millimeter. Okay, smaller tubing, you can get a few more tubes in, but it reduced the amount of refrigerant that we have to put in the system to make it work. And the less refrigerant you have to use, the more reliable the system becomes, because you're less likely to flood anything. So we're going to look at the furnaces. This is the 80% furnace. You're going to have basically from the blower deck up, nothing changed. Okay, you still got the same burners, got 2 pressure switches because it's a 2-stage furnace. You got a 2-speed inducer, rollout switches, gas valve, igniter, flame sensor. Igniter's on the right, flame sensor's on the left. That's the same as it's always been. What changed is down below, the board changed. Okay, you now have a board with Bluetooth capability, and you have a brushless DC motor. Okay, so that's what's changed on the unit. On the 90 plus, basically everything on the blower deck and above stayed the same also. On the 96 through 92% furnaces, those are ream burners. We make them, they're stamped, and they come together as an assembly. If it's a 97 or a 98% furnace, those are Beckett burners because we couldn't get any more than 96% out of ours. So those are Beckett burners. They have an insert in them. There's other manufacturer that used them, and on propane, depending where the homeowner is getting their propane, they can rust. Okay, our burners we've never had that issue, but these Beckett burners can rust, primarily not if they're getting them from a major propane company, but if they're buying their propane from like a farm co-op or something like that, where they use a bulk truck, and they've used that truck during the summer to deliver other chemicals, and they didn't clean it out, and then they deliver a tank full of propane that's contaminated, it'll start rusting, and once it starts rusting, it builds on itself. Okay, so if you're doing a propane job and the homeowner's getting propane from God knows where, there are stainless steel burners that are available for the 97 and 98% efficient furnace. Rob can get you the part number. It's on a bulletin for him. Okay. Again, the control board changed, the indoor blower motor changed, and we'll get into those in detail. Furnace coils physically did not change. The only thing that changed on the coil was the expansion valve, and the change on the expansion valve is internal. I mean, it looks just like the one that was always on there. It still has chat-lift fittings and all that stuff. The model of the coil changed when we went to the new one. Went from the RCF to the RCFZ. Okay, there are some TXV kits that can be used if they're changing out a condenser and it had an RCF coil in it. You can buy a kit that has an RCFZ TXV on it. Okay, and now this is off topic. Aluminum coils. Back in 2015 and before, we made copper tube coils. And probably everybody remembers every manufacturer out in the world had formicary corrosion issues where you got these little champagne leaks, these little pinhole leaks in the copper. If you were changing one of those copper coils for any reason, and it's in a cased coil, typically, even if you buy a new cased coil, you just pull the old coil, leave the box, and put the new one in. If you do that, okay, we make uncased coils. Most of our distributors don't stock them. The uncased coil have a shield kit that goes over those aluminum U-bends in the back and in the front, so that when you push that coil in where a copper coil has been, the aluminum tube can't touch where the copper was. Okay, because if it does, and there was any copper oxide left on that insulation, it will attack the aluminum, and you'll end up with another leaky coil in about 2 to 3 months. Strange phenomenon. So, if you don't have the shields, okay, and you're not changing the whole box, take a damp cloth, wipe off the insulation, that foil insulation on inside the coil box, and take some foil tape, and who doesn't have foil tape on their truck? Anybody? Okay. He sells it. Take the foil tape, and you'll be able to see in the insulation where that copper tube touched the insulation. There'll be little indentations. Take foil tape and cover that on the back of the box and on the door. Well, actually, you're going to use the new door because it's got the model and serial. But on the back of the box where that tubing touched, put foil tape on it, then put the coil in it. You're good to go. You're going to isolate that aluminum from where the copper was touching. This is the furnace control board. And this is for a 2-stage. So across the top, that's where all your safeties connect. That's where the water sensors connect, the pressure switches, the limit controls, all of that type of stuff connect on those plugs across the top. As you come down the left side, you've got terminals for the transformer, the secondary of the transformer. Then you've got that terminal block that you can unplug it to do your wiring and then plug it in. It's got E1 and E2, that's your Econet connection, that's your communication bus. And then R and C, and then all of your other terminals, Y1, Y2, G, B, W1, W2, U and U2. You have your status monitor LED. You have your Bluetooth LED. If that's flashing, Bluetooth is available and you can connect to it. You have down here a terminal block that will have an aux terminal, a common, and a CS for condensate switch. Okay, those are only good if you have Econet. They only work if you have Econet hooked into the system as a thermostat. And you can change those switches from normally closed to normally open. Okay, the condensate switch is if you're doing an attic installation and you have to put a auxiliary drain pan and you have to put a condensate sensing switch in it, or if you're putting upflow and you put a safety switch in the condensate drain, so if it plugs and overflows, it'll shut the unit down. If you have Econet, you can set it up so if the homeowner has the app on their phone, it will send the homeowner a alert telling them, hey, your drain is plugged. You need to have your contractor come out and clean your condensate drain. Or if it was horizontal and that switch is laying in the bottom of the auxiliary drain pan, and it senses water, it's going to tell them, hey, you've got water in that auxiliary drain pan, we shut your unit down. On the 96s, you have a terminal block down here for a supply air temperature sensor and an outdoor temperature sensor. Okay, so if you were going to do a dual fuel system, you're going to put a 15 SEER unit in on the outdoor, which is just a 2-stage compressor. It's not communicating. You have to put some sort of a sensor out there to sense the temperature so that you can set the balance point, switchover point, where it shuts the heat pump off and brings the gas furnace on. So there's a place to wire that temperature sensor. If you want to, for an accessory, you can put a supply air temperature sensor that will go in the duct. Okay, the return air temperature sensor is embedded in that board. If you add the supply air temperature sensor, when the unit's running, you can look and see what your temperature drop across the coil is without taking the temperature. You can just go to the Econet or the app and it'll and look at supply air and return air temperature, and it'll tell you what your temperature drop is, or if you're in heating, it'll tell you what the temperature rise is. Over on the other side, you've got humidification terminals, electronic air cleaner terminals, line voltage connections. Again, that shows where all your safeties are. You've got a high voltage humidifier connection that you can hook a transformer to, step down transformer. You go from 110 down to 24 unless you're using a 110 volt humidifier. Your inducer, and that's got three plugs on it, so you know it's a 2-speed inducer, so it's a 96% efficient furnace. Your blower motor connection, neutral, spark igniter, and there's your Bluetooth antenna. We've had some cases where that little, even though it's moved back into the board and that's sticking out, we've had a couple cases where that breaks off, and if it does, you have to have the door open and be right on top of it to make a Bluetooth connection. We are in the process of changing that, and the antenna will be embedded in the board so that it isn't sticking out anywhere, it can't get broken off. Indoor blower motors, we're switching to constant torque with PWM signal. We're still using like a 97 and 98%ers are still ECM motors. Air handlers, basically the same thing. You have your blower motor connection, humidifier connection. That's a big deal for us up here in the north. The first 20 years I worked for RUUD, we never had a humidifier connection on an air handler. When you mentioned it to anybody down there, they hissed at you and said, "What do you mean you want to run that and you want to bring humidity into a house? Are you nuts?" They didn't understand the concept that when heat pumps are running and heating and it's cold out, the air dries out, and we need to bring in humidity. Yeah. So we finally talked them into it, and so now you have humidifier connections. We have ERV connections, okay, which is kind of funny because we didn't used to worry about bringing fresh air into a house. I mean, you had enough leakage that you could get fresh air into the house. And then they changed the building code. They changed the building codes and they tightened up the construction. They made them so tight, and they wrapped them in plastic. They made them so tight they would sweat and they would mold inside the house, right? So to fix that, they said, you got to bring in fresh air. Well, if you had not tightened it up in the first place, you would have had fresh air. So they either have to bring in a 6-inch pipe or an 8-inch pipe and hook it to the duct system and bring in outdoor air so you have some makeup air, or they'll use an HRV or ERV, and what that does, it's an air exchanger. So it's discharging warm air and bringing in cold air, and it goes through a heat exchanger, so it kind of preheats the cold air when it's coming in. So we have a terminal up there, and that's what the reason for that terminal is. When the HRV or ERV is working, it's connected to the duct system. And when the control says we need to bring in fresh air, the HRV or ERV starts, but you also need to start the furnace blower so it can circulate the air and bring in the fresh air and put it in the house and take the old air and get rid of it. So that's part of your fan operating is part of the ERV system. We have the same auxiliary switches and condensate switches, electric heaters, which changed. The old board had kind of a round plug with a flat on it. The new one are square. The difference and the reason for that is the new heaters, when you plug them in, let me back up. The old ones, you had to manually go into the Econet control and set the blower speed for your electric heat. So if you were running straight air on an air handler with electric heat, you didn't want, we had our blowers up here set for like 15 kW. Well, if you send it down to Florida or Alabama where they run 5 kW and you're running that much airflow, it was cold and drafty. So they slowed the blower down. The heaters today have a resistor built into the plug so that when you plug it in, it automatically tells the board what size heater is installed, and it will automatically adjust the airflow for you. Just like the advantage of using that 15 SEER unit or 16 SEER, anything that's communicating, those systems are self-discovering, so that when you power them up, the outdoor unit communicates to the Econet and says, I'm out here and I'm 3 tons. The Econet tells the indoor blower unit, whether it's an air handler or a gas furnace, hey, we got 3 tons out there. We need that much airflow. And it will set it all up to the factory default settings for you. You can tweak the airflows, but the base settings are done automatically. If you have an air handler and you plug the new heater in, it will automatically set the airflow up for those heaters. If you have 15 kW or larger, they're all 3-stage heaters. The way there's only 2 banks of heat on a 15 kW. There's a 5 kW bank and a 10 kW. And the way you get 3 stages is that when you need electric heat, it brings in the first stage is 5 kW. If you need more, it shuts that 5 kW off and brings on the 10 kW. If you need more than that, it cycles that 5 kW back on. So you go from 5 kW to 10 kW to 15 kW. All automatically. Okay? We also, how many of you guys do weird stuff with hydronic heating? I got this down in Cincinnati. I was shocked. What we call the New England dual fuel system. Okay? They will take an air handler with a heat pump and they'll put a hot water coil in the supply air. So instead of electric heaters or a gas furnace, if they have a boiler, they'll stick a hot water coil in the supply air. Well, how do you turn, huh?
I've done on a commercial, but not residential.
They do it in residential up, if you get up into New England, in Mass, New Hampshire, Connecticut, they do it all the time.
Well, I know they do it in Pennsylvania too. My brother-in-law needed to provide. He wondered if I'd drive out there and put one in. I told him, no.
You don't want to deal with that mess. Anyway, we make a plug, and I sent it, I don't know if I sent it to Chris or not, but I sent it to Rob. We make 2 different plugs that plug into that heater. Okay, that just gives you 24 volts. And we've got one with a resistor in it. We've got one with a resistor in it that identifies that you put a hot water coil in a plenum. So when the heat pump's running and you need auxiliary heat, it opens up the zone valve or whatever that coil and turns the fan on. We have another plug that says you've got radiant heat. So when the heat pump can't keep up anymore, like dual fuel, and you were going to switch to gas furnace, if you have radiant floor heat or something, it shuts the blower down and brings on the boiler for your radiant floor heat. Okay, so that's a couple different options that you have if you run into that. We got low voltage terminals for the transformer, all of your communication terminals. And then up the left-hand side, you got electronic expansion valve, suction temperature sensor, suction pressure sensor, water temperature sensor. That's only for hydronic, so that if you have a hot water coil in there, it will not bring the blower on until the coil is hot. And then outdoor air sensor and return air, because gas furnace has the return air sensor built into the board. We can't do that on an air handler because the air handler has a draw-through coil, so the return air would be what came off the coil. So you have to get two probes, one that goes into return, one that goes into supply, then you can do the temperature drop and stuff. Okay, so basically we talked about the coil already. It's the same as the old coil, except it has a different expansion valve on it. Furnace coils and air handler coils are different, and the difference between them is the drain pan. A furnace coil drain pan will be white, or it will be black and have metal underneath it, heat shields underneath it. Okay. You can't use an air handler drain pan on a gas furnace because that's not high temperature material that's on the drain pan. If you set it on top of a furnace, it's going to melt. Okay, but you can, if you get stuck in a bad position with an air handler, the coils are the same, the drain pans are different. So if you have a bad coil on an air handler, you can get a furnace coil, and all you have to do is swap the drain pans. Take the air handler drain pan off that coil, put it on the furnace coil, and this coil will slide right in there. Because most distributors don't stock, and even our parts department won't have the air handler coil. So you can use a furnace coil, you just have to swap the drain pans. One of the things you want to watch is if the coil is narrower than the furnace. Some of the furnaces are wider than the coil. You want to move the coil up 6-8 inches and transition the duct from the furnace up to the case coil so that the air flows. You don't want to put a flat pan in there. We already talked about the heaters and how they'll self-configure. The installation process, there's some difference on these mid-efficiency units in that this is the optimal control system. Okay, you're using our Econet control, and you're running RC, E1, and E2 from the Econet control to the indoor unit to the outdoor unit. Okay, that's a fully communicating system at that point. So whatever the Econet control says it needs, the blower speed is going to adjust to whatever the compressor tells it needs to have for airflow. If people are hung up and really want to have a Honeywell because it'll do whatever, okay, whatever their feature is that they're selling, you can do that. It's 2-stage heat and cool stat, and it's only 2-stage 24-volt heat and cool stat to the indoor unit. From the indoor to the unit to the outdoor unit, it's still 4 wires. Okay, so it's still communicating from the indoor unit to the outdoor unit so that when the compressor is running, it's going to tell the indoor unit what airflow it needs. Okay, even on, and that's even a plus on heat pumps, because on a heat pump, you're going to run more than 4 wires to the outdoor unit anyway. It's kind of a pain on air conditioning because you guys are used to running either 2 or 3 wire, depending if you've got a 2-stage compressor or a 1-stage compressor to the outdoor unit. So there's a couple of other things that we don't have them here, but in the installation manual, there is a wiring diagram for how to wire an external transformer. Okay, you're going to put a 230-volt to 24-volt transformer outdoor. It cannot be mounted in the unit. So you got to get a weather-tight box and mount it next to the disconnect or something. Okay? And it will explain how that's got to be wired. That transformer's got to be in phase with the indoor transformer. So you've got to check the phasing. So that's one option. If you can't pull a new wire, you got 2 wire that's stapled in that's above a finished ceiling, and for whatever reason you can't get new wire out, you have that option. There's also an option, not an option, but all these inverter units, the 18 SEER, the 20 SEER, and these new 15 and 16 SEERs, you can run them with a single stage thermostat for emergencies only. So that if you are called out and they have no cooling or they have no heating, you can take, and you don't have a new Econet, you can wire a single stage stat. And there's a diagram, looks just like this, on how to do the connection. And basically, you're going to go from Y1 on the stat to Y1 and 2 on the indoor unit, and you're going to tie those 3 wires together, and you're going to run, there's on the outdoor unit, there's more than R and C and E1 and E2. There is also a Y terminal on that block. You're going to run a wire from that Y terminal in, and you're going to put it in to that Y1 and Y2 cluster. So you go from Y from the thermostat to Y1 and 2 in the indoor unit, and from there you go Y to the outdoor unit. And that's a single stage. It's a really expensive single stage 16 SEER or 15 SEER. Okay. If it's a heat pump, you still have to make provisions to get B powered for heating. Okay, to energize the switchover valve. But that will get you out of a jam if you're called out at late and you don't have an Econet control with you. So, and those are in the installation instructions, right at the same location that these are. Okay, zoning on these mid-tiers, you're only allowed 2 zones with a bypass. And they're coming out with the minimum airflows for them. Because you have to, you know, what we do different than EWC or Honeywell or Arzell is that regular 24-volt aftermarket manufacturers of zoning systems don't care what about the life expectancy of a compressor or a heat exchanger. It's not theirs. They only care about opening and closing dampers, right? Manufacturers of equipment that have zoning, we want to give you zoning, but we want to do it in a way that the compressors are protected and the heat exchangers are protected. So if you have one zone, if you have a 2-stage system and you've tried to put 3 zones on it, usually one of those zones ends up being really tiny. So if it opened, you couldn't meet the minimum airflow requirement for even low-speed heating or low-speed air conditioning. We won't allow it to come on. If you can't meet the airflow, we won't allow the system to come on. It'll sit there and wait until another zone opens, and then when the 2 zones open, you can meet the minimum airflow, and it'll let it run. But it won't let that little zone open and operate the system by itself. As far as tools, no different than what you had. How many of you guys are using mechanical press fittings? Nobody's using, everybody's brazing still? Okay. Well, I mean, in some areas they are using them. Up in New England, they use them a lot. The press joint fittings. We haven't tested them. We don't know. I mean, and I've been around long enough through compression fittings, flare fittings, single shot quick attach fittings, you know, all of these different easier than brazing fittings methods. And the one thing they all had in common is they would eventually leak. So therefore, if you braze it in and you use silk-floss and actually braze it in, it's not going to leak. They're using press joints, and I haven't heard of any issues yet, but we haven't tested them and they're new. They haven't been around that long, so I don't know if it's a good thing or bad thing. Coming up, when 454B comes out, the fitting on the tank where you would normally connect your hose is a left-hand thread. Okay, so there is an adapter from several manufacturers. The one I bought is from J&B. It is just a little union coupling thing where the left-hand thread to put it on the tank, and then it's got a male right-hand thread to hook your hose to. So you're going to need to get one of those. You can wire all of these as long as you are careful with 18 gauge regular thermostat wire. Solid wire, stranded wire, we don't care. If you're going to run the thermostat wire in a joist space with a bunch of high voltage where it can pick up electrical noise, you're probably going to get communication errors. Okay, but as long as you keep it away from a bunch of high voltage, you know, mine's run for years. I run the low voltage and high voltage through a wall and through the hole in the basement wall to come outside, side by side, never have a problem. But if you run it for any long distance, you may end up with some noise. You may have to isolate it. You may have to run shielded cable. But as long as you take some precautions, you can just use 18 gauge stat wire and it should be good. Okay, when you're starting up a heat pump or an air conditioner and you chose to use a 24-volt thermostat, you're going to have the app to do it, because you can't make any adjustments for airflow, you can't make any adjustments for defrost temperature, termination, nothing without the app. How many of you have the app? Okay. How many of you have a RUUD account? Okay. When you download the app, if you have a RUUD account, that's going to be your credentials to log into the app. Okay. If you don't have that, you can continue as a guest and you can still charge, you can still set a unit up as a guest. But there's a bunch of other stuff that's on that app that you don't have access to unless you have an account. If you want a RUUD account, you have to get that through 2J Supply. Or you can go online and apply for it. We're going to come back to 2J because this is their sales territory, and we're going to ask their permission to give you the account, because we don't want to give it to carrier dealers and Trane dealers and Lennox dealers and all that. So when you get your first unit, it'll have a blue sticker. You can scan that, and that will download the app on your phone. Or you can go to the iStore or to the Google store? Okay, so you've got system setup, diagnostics, system status, charge mode. You can scan the codes, get technical support, and this is technical support for the app, not technical support for the equipment. Okay. If you call me, if you call me or Rob or Chris and want technical support for the app, we're going to go, huh? If you call them and ask them for tech support on an air conditioner, they're going to go, what? Okay, they do app stuff. We do heating and air conditioning stuff. Okay, so within 45 seconds of powering up, if you have Econet, it should automatically detect what outdoor unit, what indoor unit you've got. It's important that you start it the right way, power it up the right way. If you power up the indoor unit before you power up the outdoor unit, you're going to get a fault code that says you have no 240 volt to the outdoor unit. So when you power up an Econet system, power up the outdoor unit first, then power up the indoor unit. And when it discovers a unit, it'll know, okay, it's got power and everything there and life is good. Okay, so once you power it up, it's going to take you to the basic settings. Okay, the default settings. You can make other adjustments. You get outside unit selection. You can clamp on an 18-SEER. You can clamp the outdoor unit because it has an overdrive. When it gets a big demand, most compressors run at 3450 RPM. The 18-SEER will go to overdrive and it'll go up to 7,000 RPM. Okay, when that thing's running at 7,000 RPM, it makes a different operating sound. It does not make noise. It makes a different operating sound. It sounds like a motor that's running 7,000 RPMs. Okay. When I field test, I have the original 20-SEER field test unit in my house. I removed a Train XL16i, and which was a 2-stage. Good, good unit. My wife hated it in that it was quiet, but when the contactor snapped in, she could hear it at night because it sits outside our bedroom window. So when I heard in the lab this thing running at 7,000 RPM and I'm going to field test one, I'm going, maybe I ought to move it to the backyard. Now it's a field test. I'm just going to put it back where the old one is. She's never said a word. Okay, but noise is subjective. Okay, what's noisy to me may not be noisy to you. Just be aware that this thing, if it's an 18, it's going to wind up at 7,000 RPM. If it's sitting outside the window or it's sitting between two houses that are close together or something like that, the sound is going to reflect off those houses and you're going to start a family feud between the two neighbors. So just be aware of that. You can clamp it. If it's too noisy, you can touch that and you can drop that maximum speed. You can drop it down to 4,000 RPM if you want to try to make it more acceptable. You can adjust the cooling and heating airflow. You can adjust utility input. Utility input, that's that U and U2 that I was talking about. Some of the utilities, Detroit Edison started doing it in the early 80s. They gave homeowners a really favorable electrical rate if they would allow them to put an interrupter and they broke the Y circuit and they could shut the air conditioner or heat pump down for 20 minutes an hour up to 5 hours a day. But they gave a really great electric rate for everything. It was not metered separately. It was all one meter. And they dropped the price like 3 or 4 cents a kW. So it was a pretty good deal. They used it for load management so that in the afternoon when everybody came home and the demand went up, they didn't have to bring the standby generators up, bring as many of them on or bring them on as soon as they normally would. They could manage their standby power, their standby generators. You see that today with utilities offering good deals on digital thermostats where you can connect to the internet and they'll give you a special rate, but they can control that through the internet and they can manage the temperature settings. Okay, so
They must not be married.
yeah, my wife still believes that if you turn it up, it's going to warm up faster or cool down faster. Okay, whatever. So anyway, we don't want them breaking any low voltage circuit on a inverter system because it'll give you a communication fault. So we put this U and U2 terminal in there. And the way you do that is you would put a little 18 gauge thermostat wire jumper between U and U2, go to the Econet and change that from no to yes. And then when the utility comes out to put their interrupter in, they just take the panel off, pull the jumper out, put their interrupter in there, and they can test it so that when they power the interrupter, it breaks the circuit and shuts the outdoor unit off, but it won't give you a fault code. Okay? Heat source. You know, if you got electric heat backup heat or you got dual fuel, you want both. Do you want to lock out the heat pump or do you want to lock out the gas furnace? I never lock out my gas furnace. Do I lock out the heat pump? Yes, at 22 degrees. I'm on propane and that inverter pump will heat my house down to 22 degrees. A 3-ton pump doing 3,300 square feet. Do I want to use defrost? Do I want auxiliary heat to come on when I defrost? Yes, I live in Michigan, it's cold. I don't want to bring more cold in. But in some parts of the United States, they do not. Because the defrost cycles are so short, it doesn't matter. Okay, so when you connect to the Contractor app, it will list all of the units that are on that circuit. Okay, so if you've got a gas furnace and a heat pump, it's going to show the gas furnace and the heat pump. If you've got multiple units in that basement real close in the mechanical room, you've got 3 furnaces sitting in there, it's going to bring up all 3 furnaces and all 3 outdoor units. Okay, so you have to select, once it connects to Bluetooth, if it listed more than one, you have to select by serial number which unit you're going to work on. Okay, and be careful about doing that because I had a guy up in Lansing that was working on 85,000 for a 60,000, and he downloaded all of the operating information for an 85,000 onto it. So he had to clear it all and redo it. But it took him a whole day because he couldn't figure out what was going on, what was wrong. Okay, so it's going to connect. Then you go into charge mode. Okay, you go into charge mode, it'll give you charging for cooling or charging for heating. You can charge for cool if it's above 60 degrees. Heating, you can charge between 40 and 60 degrees. So when you're in charge mode, it's going to start the unit up. You've got the EXV position. It's going to tell you what the superheat is, if it's on their handler. Tell you what the suction line temperature is. It apparently doesn't have a sensor there because it's minus 40. tell you what the saturated temperature is and what the pressure is. Okay, you can actually charge the unit and watch the Econet or the app and see what the superheat and subcooling are. On all of these units, when you're charging to subcooling, if you add refrigerant, it is, I can't stress enough how important it is that you let this system run. If you've added refrigerant, let it run for 15 minutes to get the pressures and the temperatures stabilized before you go adding any more. Impatience is what kills a lot of this, because people get impatient. They want it to happen real quick. It doesn't happen quick. Okay, you have to add refrigerant, let it run for 15 minutes, let it stabilize, and then if you need to, if you add more refrigerant, you got to let it run for another 15 minutes. It's just, that's the process. If you keep adding refrigerant before it stabilizes, you're going to end up overcharged. In heat mode, you're below 40 or between 40 and 60. It's going to connect. And it will show you basically all of the same stuff. It'll show you what the superheat is, saturated suction temperature, the pressure. And I had this conversation with Chris yesterday. We had a guy that was trying to charge, it was just a standard unit, but he was trying to charge it. He had the pressures right on, but he got hung up on the pressures. Okay, the pressures, when you're charging a heat pump or air conditioner, the pressures are the starting point. What you're looking for is getting the subcooling right. Okay, if the pressures are off a little bit, don't worry about it. As long as the subcooling is right, that's where you want to be. And if you get the subcooling right and you get the superheat between 9 and 12 degrees, you're good. You're gold. Okay, this guy couldn't get that through his head that, okay, yeah, you got the pressures right, but don't worry about it now. That's a starting point. Now you charge it, get it, you fine tune it to get it subcooling. So, if you're using the the contractor app to charge and you leave the charge mode, if you leave the charge mode, then it's going to turn off the charge mode. And you'll have to go back and restart it. And what charge mode is it's matching the airflow and the compressor speed to whatever it was when we developed the charging charts. Okay, if you don't use charge mode, then the compressor and airflow could be different than what it was when we set the chart up. So you need to use charge mode when you're charging these things. I've never done this in my life on a standard residential unit where you weigh in extra. You know, we ship a unit with enough refrigerant for the outdoor unit, 15-foot of line set, and the indoor coil. When I started in this business, we sent enough refrigerant for the outdoor unit, 25-foot of line set, and the indoor coil. If it's a typical residential system with 50-foot or line set or less, I'm not going to weigh anything in. I'm going to start it up. I'm going to put the gauges on it, make sure I've got pressures. I'm going to let it stabilize. I'm going to look and see what the subcooling is, and then I'm going to add or subtract refrigerant to get my subcooling right, and then I'm going to double check to make sure the superheat's in range. I'm not going to weigh refrigerant in. Not unless I absolutely have to. If you're doing a long line set, some of these people don't want the heat pump or air conditioner near their house, they want it 100 feet away. Yep, weigh in some extra because you're going to be short. But normal residential, it's a wasted step. Important thing about our charging charts, and this is a typical charging chart. You'll notice that we have across the top, the first two columns are both for 16 SEER 2-ton units with a RH3VZ air handler 2-ton. But if you go down through it, especially in heating, when you get to the subcooling and the pressures, the liquid pressures are dramatically different between the two. If you look at 47 degrees in the first column, it says you need 25 degrees of subcooling. But that second column says you need 40. It's important that you pick the right column. The difference is the first column is UFLF. That's upflow or left-hand horizontal. The second column is DFRF, which is downflow or right-hand horizontal. The position of the coil and how the airflow goes through the coil changes the subcooling that much. So when you're charging and you're looking at the charging chart, it's important that you get the right column. There will be, on a heat pump, there will be 2 columns for every tonnage. And it's all based on what position the indoor coil's at. If you look at 47 degrees on heating, if it's upflow, you're at 342 pounds of liquid pressure. If it's downflow, you're at 383 pounds of liquid pressure. 40 pounds difference. 15 degrees of superheat, of subcooling different. And it's all because how the airflow goes through the coil. If you're upflow, it's going up through the coil. If you're going downflow, you know, you got that sheet metal cap on the top of it, and the airflow is disrupted more going down than it is coming up. So it affects the subcooling. So, and that's on any heat pump. Doesn't have to be this mid-tier. It could be a 14 SEER. Okay, Bluetooth setup. Once you get it installed and you're connected, it's going to list the equipment that's connected. It's not going to show an air handler if you don't have an air handler connected, but you'll either have air handler or furnace, and then you'll have your outdoor unit. So which unit you want to work on. Okay, then it's going to show you the serial numbers. You select the serial number that you're going to work on. If you have Econet on the system, it's going to stop you right there and say, don't use the app, go use the Econet to set this thing up. If you have a product and say we've got an RHMV Z36, it's a communicating air handler. Apparently they put a single stage outdoor unit on it. You can select, do you have a single stage or a 2-stage, and what tonnage? Okay, because that outdoor unit is not communicating. It's not going to tell the air handler what size it is so it can set the airflow. So you have to go in the app or on the Econet control and tell it. It's a 2-stage system, it's a heat pump, and it's a 3-ton. On gas furnaces, it has factory settings for airflow. It has side return. It has +7 and +12. Factory settings, when we set the airflow charts, all of the airflow charts are developed with bottom return. Okay? There's no turns or anything. Actually, they take it and they lay it horizontally. They put 8 foot of duct on the return, and they put 8 foot of duct on the supply, and when they measure the static pressure, they put a probe on all 4 sides of the tube and connect it all together and average it. You're not going to do that in the field, okay? So that's how the factory airflow is setting, okay? So that's your factory setting. We do basements primarily. Anybody disagree with that? We primarily put furnaces in basements. They don't. Oh, really? You got that much? Okay.
Right, all down,
Okay.
platform.
Well, if you get down south, they don't understand basements. Okay, so we have basements, and we put return air boots on the side of the furnace. The airflow is more restrictive to airflow if you put in the side, and it varies. If you do a nice radius boot where it goes in, that's less restrictive than a square fitting, or somebody that just runs a piece of ductwork down, screws it to the side of the furnace, and cuts a hole in it. Okay, so I see it every day. So if you're going to do side return, you need to change that setting to side return. What all that does is speeds the blower up so that it'll pull more airflow. Factory setting, on all of our furnaces, we give you a 30-degree temperature rise range. Okay, so like a 70,000 BTU furnace, it's typically 40 to 70 degrees. So the return air, the supply air temperature is going to run at about 55 over the return. That'd be the mid-range. If you run side return, you're going to slow that down, the airflow down, and the temperature is going to go up. So if you put it on side return, it speeds the blower up, moves more air, keeps you in that mid-range temperature rise. +7 is exactly what it says. It's mid temperature range +7 degrees. And +12 is scary because you only have +15 to work with. If somebody, if you were the guy that pulled out a gravity furnace and sold these old people this high efficiency 90+ furnace that they're going to call you on and tell you it's cold in there, even though the thermostat says it's 75, they're going to want that +12, but they're going to have to make sure they keep the filter clean. And then, what do we got over there? Outdoor unit settings. If you have a heat pump, we ship it so that, and ideally when you go into defrost, it will come out on temperature. Okay, so the outdoor coil warms up, and the factory default is 60 degrees. Okay, if you're in a warmer climate and you got a shorter defrost, you can change it to 50 degrees. If you're in a colder climate, you can change it to 70 or 80 degrees to clear the coil. Okay, if you're up in Maine or, even in northern Michigan, they set them, I don't think many people change it from 60. It seems to work fine, but you have that option. If it's not clearing the coil, you can change the setting. You can tweak the airflow for heating or cooling on a heat pump, plus or minus 5 degrees, 5%. Okay, so if you've got that long duct run, a 2-story colonial, the far upstairs bedroom won't heat or cool, you can bump the airflow up 5%. Or that bonus room above the garage or whatever that will never heat or cool, you can bump it up. If it's a smaller house and the airflow is noisy, you can slow it down 5% with no big issues. And you can adjust it. It will tell you what it is for high speed or low speed. how much airflow you're moving. If you're running a gas furnace and it's a 2-stage gas furnace, you need to tell it what outdoor unit you're going to put on it. If you're putting a single stage or a 2-stage. If you were run that 80 plus furnace, 2-stage furnace, and you put a 14 SEER air conditioner on it, 2 ton, you need to tell it, okay, I've got a single stage compressor and it's 2 ton. Or if you put a 14 or 15 SEER heat pump, which is a 2-stage compressor, because all the heat pumps now are 2-stage, it'd be a 2-stage and you set it for whatever tonnage. Gas, we already talked about high heat, low heat, side return, and why you need to set it up on side return. You can set the fan off time. Fan on time is set at 20 seconds from the time it senses flame. The off time, we ship it at for cooling, we ship it at 45 seconds. So when the unit's running, compressor shuts down, blower runs for 45 seconds. If you want it to run for 60, you can adjust it. Down to 30, you can adjust it. Or if you want the blower to shut off immediately, you can set it to 0. What kind of thermostat? You know, we assume if we ship a 2-stage furnace, it will have a 2-stage thermostat on it. If you were going to use, that homeowner's in love with the T87 that's hanging on their wall, and you're going to put a single stage stat on it, if you don't make that adjustment, it will never come out of low fire. Okay, because you're going to run from the thermostat to W1, and it's going to stay in W1 forever until you get a W2 call. If you're going to use a single stage and you got connected to W1, you need to tell it, I've got a single stage stat on it. I want it to run for either 10 minutes, 15 minutes, or 20 minutes before it cycles up into high fire. Your choice. You can set it wherever you want. Okay. You can have on-demand dehumidification. Or any guys remember what on-demand dehumidification is? On-demand dehumidification, you would take a humidistat and put it in space. You hook it to the humidifier connections on the control board. And say in the summertime you want to maintain 40%, 45% humidity in the house. So you set the humidistat at 45%. When you're running in cooling, if that humidity is above 45%, then that humidistat closes or opens, and it will slow the blower down. Okay, if you're running air conditioning and you run the slower blower, it does a better job of dehumidifying. Okay, so where to go? You can slow it down 5, 10, 15, or 20%. Okay, it's cumulative. So if you already slowed it down 5% because it was noisy, and you slow it down 20% to dehumidify, you've slowed it down 25%. If you're going to get into those upper ranges at 15, 25%, you need to watch it to see if that coil is going to freeze or not. Because it could. I mean, coils freeze because you got low charge or low airflow. We are intentionally lowering the airflow. Okay, and if you want to add a coil temperature sensor, a freeze stat, feel free to do so. You can adjust the airflow for heating on a heat pump, plus or minus 5%. If you have a communicating system with electronic expansion valve, you can adjust the superheat on the expansion valve electronically. We already talked about defrost termination temperature. We ship it at 60. You can adjust it to down to 50 or up to 70 or 80. You can look at the status. Okay, you can pick the unit you got. It'll tell you it's operating and cooling. Compressor demands, the Econet is asking for 2,000 RPM. It's running at actual 98% of that. And that means it's running at 1,960 RPM. The outdoor temperature is 78.4 degrees. It's measured on the sensor that's in the outdoor unit. Liquid line temperature is 70 degrees. And the compressor temperature is 70.2 degrees. Okay. When you get into the air handler, it's on. It tells you what kind of airflow you're asking for. What is the current CFM? What is the current RPM of the motor? What's the static pressure? You ain't got to measure it. You can get the static pressure right off the Econet or the app. If you added the temperature sensors for the duct, you can get the supply air and the return air temperature and see what your temperature drop or your temperature rise is. What's the outdoor temp? Suction line temperature, saturated temperature, suction pressure. Is the G input on? G input is for the fan, so that if you have an ERV and it calls for fresh air, it will kick the fan on. You run a wire from the ERV to the G terminal. EXV position, what is the superheat? What position is the air handler, EXV? It's at 60%. Tells you what the heating airflow is on electric heaters for high, medium, and low. What size the electric heater is. Is it on or off? Any current alarms on the system. Condensate input, is it hooked up? Do you have a condensate safety switch on it? Auxiliary input, do you have like a smoke detector or a CO alarm or anything like that hooked to it? And the Bluetooth program and the software version. And more today, we've always said, hey, when you call us, we need the model and serial number. And more today, we're starting to ask for software versions, because sometimes it's not a mechanical issue, it's a software issue. And so you tell us, okay, we got this software version 13. Oh, yeah, okay, we know about that. We need to get you a new control with version 14 on it. So if you've got a gas furnace, it'll tell you if it's on, what the commanded airflow is, what the current airflow is, what the RPM of the motor, static pressure, supply air temperature, if you put the extra probe, return air temp, outdoor temp. It's not going to give you suction lines or saturated or suction pressure, G input, and nothing for auxiliaries. It'll tell you, do you have a low call for first stage or second stage? If low call, nope. First stage isn't running. Second stage is, it's on. Low cool is not active. High cool is not active because it's running in high heat. EXV is not in play. Superheat's not in play, but the inducer's on, and it'll tell you the inducer's on. It'll tell you that the low pressure switch is closed and the high pressure switch is closed. The furnace is on. Is it a single stage gas valve? Nope. It's a two-stage gas valve. And it would have to be because it's in high fire. It says so over here, it's in high heat. Is the flame on? Yep, it's burning. Its flame is active. What's the flame strength? You can't measure it with a DC microamp meter anymore because it's a digital signal. So you're either going to get it on the app or the Econet, and it's going to tell you it's normal or low. Okay, so it's normal. Limit switches are closed and the main limit is closed. You did all of that. You never pulled a volt ohm meter. You never pulled a manometer to measure your static pressure. You never pulled a temp tester to measure the temperature rise on the furnace or the temperature drop in cooling. You did all of that without any tools. Did it all on the Econet or the app. And we're not even going to charge you for the app.
That's what you get for free, huh?
That's it. I just bought a new set of gauges because I had to go work on a 454B field test unit. So I needed a set of digital gauges that would do 454B. $500 later.
High pressure is those things compared to 4 down.
Lower?
Lower.
Yeah, a little bit lower. It'll be okay. It's yeah, it's just a little bit lower. So when you get into heat pumps, it'll tell you the RPM that you're asking for, what the actual speed is, what the actual RPM is, what the outdoor temp is, what the liquid line temp, compressor temp, saturated temp, suction line temp, coil temp, liquid pressure, discharge temperature, subcooling, and superheat. You didn't hook any gauges up. You didn't hook any temp testers up, but you got all of this. You can go through and get all of that right off the app or off the Econet control.
Trying to eliminate our job, huh?
It will measure the voltage, the actual voltage that's on it. It'll measure the total AC input current. It'll measure the compressor current. Whether you want the hold off timer or utility, what position do you want the EXV in? What's the saturated suction line temperature? Do you want the utility input set up? Suction pressure, saturated temperature, and then the Bluetooth and the software version. So we'll breeze through this real quick. This didn't change. This is normal sequence. When you get a call for heat, first thing on a gas furnace, first thing that happens is not the inducer start. The inducer isn't the first thing that happens. First thing that happens is the board checks the safeties to make sure they're in the normal position. If they're in the normal position, then it will turn on the induced draft blower. Once it closes the pressure switches, you go into a 30-second, actually 34-second pre-purge to make sure that you're clearing the vent system. Okay? After the 30-second pre-purge, it goes into an 8-second trial for ignition. and it gets busy quick. Okay, during that 8 seconds, it has to start sparking the electrode, open the gas valve, light the burners, and sense flame. All in 8 seconds. Okay, if it does all of that and it stays running, then at the end of 8 seconds, it goes, at the end, from the time it starts sensing flame, it goes into a 20-second timer, and 20 seconds from the time it senses flame, it turns the indoor blower on. That is not adjustable. Okay? At the end of the call for heat, thermostat says it's warm. It breaks the circuit, shuts the gas valve off. You have a 10-second post-purge, and then the blower off delay, which is 90 seconds, is where the factory sets it. You can adjust it to 120, 150, or 180 seconds, wherever you need to set it. And that, it was that way on all the old product, so nothing has changed there. Heat pump operation. If you call for heating or cooling, if the outdoor temperature is above 95 degrees, regardless of what the indoor temperature is, when it calls, it's automatically going to go to high speed. It's not going to go through the staging process. It's going to go automatically to high speed. Or if the outdoor temperature is below 32 degrees and you're calling for heating, it's automatically going to go to high speed. If the saturated liquid temperature is greater than 120 degrees, it's going to go to high speed. Or if the saturated suction temperature is 0 or below, after 15 minutes of runtime, it will go to high speed. Okay? If the pressure relief valve, it has that valve I've mentioned a couple times, it equalizes the pressure during the off cycle. They won't start if there's more than a 20-pound, it has to be less than a 20-pound pressure differential for that compressor to start. If there is a differential of more than 20, the lockout timer was set there and hold at 5 seconds. It won't allow it to start until that pressure is equalized. For low ambient cooling, it's built into the system. Outdoor fan will cycle on at 80 degrees Fahrenheit, and it will cycle off at 64 degrees or 40 pounds. So if you hit those, the fan's going to cycle off. After 2 hours of accumulated runtime, the compressor is going to run up to 2400 RPM. It's going to run for a minimum of 2 minutes for an oil return. Okay, because if it's been running for a long, my unit runs for all the time, and it's running really, really slow. So you may not have enough velocity to get the oil back to the compressor. So after 2 hours of accumulated runtime, it's going to go to 2400 RPM, just so it can make sure it gets the oil back to the compressor. Okay, it'll run for approximately 2 minutes. Defrost initiation on this is the same as it did on the board. We just took on the old defrost boards that we put on the 14 and 15 series. Okay, we just took all that information and built it into this board. So the outdoor coil's got to be below 35 degrees. Compressor had to operate for at least 34 minutes with a 35-degree coil or below. And the outdoor control unit determines, based on what the outdoor air temperature is and the evaporator temperature is, whether you need to defrost. And it will learn when you need to have a defrost, and it'll go into a defrost if needed. When it goes into defrost, just like the old units, it'll reverse the cycle, except that Remember on the scroll compressors, we shut the compressor off. When you go into defrost, we shut the compressor off, we switch the switchover valve off, and then we turn the compressor back on in cooling mode then, with the fan off. We defrost the coil, then we shut the compressor off, switch the switchover valve back again, and turn it back on. Because it would, remember when the scrolls would chatter? If you switched them without it having a time delay, it made a god awful noise and people got all excited. Okay. With the electronics and the software that's on here, on these inverter units, they don't have to shut the compressor off. They find a sweet spot, and when it needs to go into a defrost, it will speed up or slow down the RPM of the compressor to a point where they can switch and it won't chatter. Okay, now the mid-tiers aren't going to chatter anyway because they're a twin rotary, but the high efficiencies would. And they do that. The way they did that was they just matched the RPM to where it needs to be, and they can switch it without it being noisy. The two-stage heat pumps, the 14 and 15 SEER, they still have the old board on it. They still have the time delay on them. So when you go into defrost, reversing valve gets de-energized. Okay, so defrost cycle. You de-energize the reversing valve. Okay, put it in cooling. Shut off the outdoor fan motor because the outdoor unit coil is now the condenser, so it's going to get hot. We don't want to bring cold air across it while we're trying to melt this frost off of it. And depending on how you set it up, you're going to bring on the auxiliary heat, whether it's electric heaters or gas furnaces to temper the air, because the indoor coil becomes the evaporator and you don't want to dump cold air into the house. Okay? That's, in my part of the world, that's how we do things. There is an option on the Econet so you can disable that if you are someplace where it's a short defrost and they don't care. Some places, some of the states where you get rebates and stuff like that, California, you can't have that happen. Remember, it's a land of fruits and nuts.
I call it California.
Huh? Yeah. Okay, we already talked about defrost termination. They defrost at different RPMs. They're going to ramp up to 70%. Okay, when it goes into defrost. If it's running through the inverter. If it's online, and you'll hear those two terms. If it's running on inverter, it's running at 70% or lower. If it's running online, it's above 70%. Okay? If it's running online, it'll keep running at 3450 for defrost. And if the outdoor temperature thermistor fails, it is going to go start defrosting on time. So it will defrost every 34 minutes when the coil temperature is below 35 degrees. So if it's cold outside and it's defrosting every 34 minutes, it's probably got a bad coil sensor. Defrost termination is at 60 unless you change it. If the important part, if you go into a defrost, it's running in heating and it goes into a defrost cycle and the call for heat is satisfied. Okay, it's come up to temperature. The unit will stay in defrost until the defrost cycle is complete. It's not going to immediately shut down, and then when you go to call for defrost again, or for heat again, go into a defrost cycle. It's going to complete the defrost cycle, then shut down. This is just showing, I'm going to show you the difference between how an Econet unit operates versus a 24 volt. On an Econet, when you call for heat or cool, it goes to 40%. And then it's going to modulate up and down, depending what the load is, up to 70%. So between that 40 and 70% operating range, the compressor speed and blower speed can modulate up and down to meet the demand, whatever it has to do. When it gets to a point where it needs more than the 70%, then it goes to what they call line voltage. The inverter is going to synchronize to 60 cycle. It's going to close the contactor. It's going to go to 100%, and it's going to stay at 100% until the call for heat or cooling is satisfied. Okay, so once it goes to 100%, it can't modulate back down to 70. It stays there until the call is satisfied. 3450 RPM with no overdrive. This is what happens if you have a two-stage heating 24 volt thermostat. When Y1 calls, it goes to 40%. It's going to stay there somewhere between 5 and 12 minutes, generally. 20 minutes maximum at 45%. At the end of that 5 to 12 or maybe 20, it's going to cycle to 65%. It will stay there until you get a Y2 call. Okay? And then once it goes to Y2, it goes to 100%, and it stays there until the thermostat's satisfied. So what you lose with Econet versus 24 volt is, with Econet, you're going to get less equipment cycling because it's going to modulate up and down instead of turning on and off. You'll get better diagnostics. Okay, you can put somebody else's 24 volt thermostat, and I've got no beef with Honeywell or White Rogers or any of those folks, but they can't communicate with our system and tell you what the fault codes, or they can't tell you what the suction line temperature is or what the compressor RPM is. It's a 24, regardless of how fancy it is and what it can do on the internet and stuff like that, it's a 24 volt thermostat. All it can do is turn the system on and off. It can't communicate any fault codes or anything to you. So that's one of the big advantages. We get longer part load run times because it will modulate between that 40 and 70%. And by doing that, you're slowing the blower down and slowing the compressor down, you get better dehumidification. Okay, and the best example is my own house. When we had a two-stage heat pump, we kept it down at, I needed, your point, I needed a 2.5 ton. I had to put a 3 ton in. Okay, so I ran low speed most of the time, but it still cycled on and off, and get it to dehumidify correctly, I had to have it set at 72. When I put the inverter in, it's now set at 74. But the humidity stayed the same because I'm running at that lower speed for longer time. That's what the Econet will do for you. Okay, it'll run it lower for a longer time in that 40 to 70% range. So it gives you better temperature control, decreased fan because the fan isn't running high speed. It's sometimes it's barely running. When it's down at 40 and 40%, you can stand right next to it. You probably won't even hear the fan run or the compressor. You've got connectivity, auto configuration. on it. And part of the connectivity is that with Econet, the homeowner can download the Econet app and they can communicate with their product. If they get a fault code and they're on vacation in Florida, they get a fault code on their phone, they can call you and say, hey, my neighbor's got a key and I've got this fault code that says my blower motor failed. I need you to go out and take a look at it. Okay, or if they're coming back from vacation and they had set it back, the temperature back, they can go on there and raise the temperature up so that the house is warmed up or cooled down by the time they get home. They can do all of that. If you get mad at your wife, you can lower the temperature in heating down to 65 degrees. And if you're smart, you can go in the Econet and you can set the Econet up so that they can push buttons all day and it won't change anything. You can lock it. So, okay. So the service part of this, guys, there's diagnostic codes. You get all these different codes. There's codes for indoor units, outdoor units, air handlers, gas furnaces, all of that. I'm gonna minimize this and this. You can get this on the app, or okay, if you go into my RUUD and you open it up, on the left-hand column, there's a blue bar that says at your fingertips. You click on that, there's a drop down, and it will have a temperature and resistance chart for thermistors. Okay, and most of those charts are in 2 to 3 degree temperature banks. This one is in 1 degree temperature bank. So no matter what the temperature is, you can measure the resistance and measure it and get an accurate reading. Okay. The second thing that's in there is Econet Technician. That's also on the app, and you can look at it by code, or you can pull up the product that you're working on and it will list all of the codes for that product. And if you click on it, if you're going to work on the outdoor unit and it was a P16, it's going to show you all of the active alarms right here. These are all the alarms it saw. You had a model configuration error, it was missing the inverter communication, coil temperature thermistor failed, suction pressure sensor failed. Well, if you looked at an A953_0, then you can go to the diagnostic results and pull that up, or you can go on your computer to the Econet Technician and it tells you, okay, this is your fault code. This is what can cause the fault code. These are the tests you have to make to figure out whether it was a sensor or if it was a board or whatever. It takes you step by step through checking all these different things. It tells you what you should see and what to do if you don't see it. And then it'll give you a suggestion, say, okay, this is what you need to do. You need to replace that sensor. And it's there for every fault code for everything we make, whether it's gas furnaces, heat pumps, air conditioners, air handlers, Econet zoning, Econet thermostats, communication errors. All of those are there, and if you click on it, it'll take you right through how to diagnose it. So, and that's on the app. Okay. When you call Rob or Chris and you give them the fault code, it's important that you give them, it's always going to end with an underscore and a letter. It's important that you give them that letter, because that tells them A is an alarm, T is an alert. Okay, an alert could be something no more than on the Econet control, you can set up alerts that are reminders. Tell the homeowner when to change the filter, when to change their humidifier pad, when to change the UV bulbs, when to call their service tech to come out and do clean and check. You know, all of those normal things. Alarms are limit trips. And there's two types of alarms. There's alarms that are not critical, okay, and they'll allow the system to keep running. And then there's critical alarms that say, oh, no, this is not good. We're going to shut the whole system down. And then the last letter, O is outdoor, A is air handler, F is furnace, C is a communication error, S is a system error, Z is a zoning. Okay, so when you call them or you text them, you need to give them that last letter so they know where to look to find, because when you give them that code, they're going to go look on their app or on the computer and find out, okay, what is this thing and how do we go about going through it and checking it? And we don't have all this stuff. There's too many of them to memorize. To see current alarms on the Contractor app, you can pull that up. And in current, it shows all the current alarms that are on that system. It shows alerts. Support, that is support for the app, not support for the equipment. Equipment, okay? If you're calling in and you know we're going to ask for the model and serial number, you can click on equipment. It gives you the model number, the serial number, and the software version for every piece of equipment that's connected. It'll show the outdoor unit, gas furnace, the Econet control, everything. Anything that has a model, serial number, and software, it will list it. And you can just take a picture of it with your phone and text it to them. So it's got some indicator lights. The first one is just tell if it's on and flashing, it tells you Bluetooth is available. You can connect to it. If it's on and solid, somebody's connected to it. The next green light is your cooling. I think we already talked about it. One flash is 10%. The amber light is for heating. Every flash is 10% of capacity. If you momentarily press that blue button, it'll bump start it just to tell if the compressor will run. Bluetooth application. If you're having trouble with Bluetooth, it will. There is an 800 number that you can call to get assistance. If you're troubleshooting Econet, this is what you should be getting. If everything's disconnected, okay, so the wiring isn't hooked up, you should be able to go down to the furnace and measure E1 to E2, you should have 3 volts DC. E1 to common, you should have 3 volts DC. E2 to common, you should have 0 to 0.2 of a volt DC. Okay, that's normal with nothing connected. If you connect everything, all of the equipment, E1 to E2 should fluctuate 1 to 3.5 volts DC. Okay, E1 to common, 2.5 to 3.5 volts DC. And E2 to common, 0.1 to 1 volt DC. That's telling you it's communicating the Econet with the indoor unit to the outdoor unit. They're all communicating, and if they're pulsating in those voltage ranges, everything is right with the world. Contactor, basically troubleshooting it. You're going to troubleshoot it the same way you normally do, just don't push anything in. We already talked about line voltages. You guys have pretty good voltage. It stays pretty steady, 230 volt. Yes, no?
Yeah.
Yeah. Okay. In most of the territory I have, it does. It stays pretty standard. If the drive fails to sync to the line voltage, okay? Remember I said, if you go to line, it's got to sync to 60 cycle. Before it switches from the inverter to the line, the drive's got to synchronize to 60 cycle. If it doesn't, then it will delay jumping from the inverter to line voltage. Different things that can cause that is you got an overcurrent situation, drawing high amperage on the compressor. It's over temp, compressor's running hot, so they're not going to allow it to go to a higher RPM and run hotter. You could have an open phase on one of the compressors on the compressor. Contactor might not be closing, or you could have a lock rotor compressor. All of those will keep it from jumping from the inverter to line voltage, to line. The compressor will attempt to start every 5 minutes. After 6 attempts, it's going to display a fault on the Econet SmartStat or the app. It could shut down for 30 seconds and try to cool off and reset. After 6 strikes, it goes into a hard lockout. It means you got to go out on the job, cycle power, and see what faults are on it and try to find out what's going on with it. You say there's a lot of different devices that protect it. The high pressure switch, one end connects to the UODC, the other connects to the inverter, and it's set to trip at 610 pounds, reset at 490. 610 is scary, isn't it? If you're an old R12, R22 guy, it's real scary. We don't use low pressure switches. We use the pressure transducers as pressure switches. So we take the pressure transducer and the suction pressure transducer. We use that as a pressure switch. And we change the settings by using the software. Okay? So we have one set of settings for cooling and one for heating. In cooling, the low pressure switch is going to open at 50 psi. It's going to close at 95. That's in the cooling mode. In heating, because of the way 410 operates, it drops really low. In heating, it's going to open when it gets down to 15 psi, and it'll close at 40. But it's all software because there's only one pressure transducer. It just matters if you're in cooling mode or heating mode. The liquid pressure transducer opens at 610 pounds, period. If you have to change a transducer, there is supposed to be, okay, I said supposed to be, a valve core in that fitting so that you can change the transducer without recovering the charge. Okay, you break it loose and then you You know, I mean, it's like disconnecting your gauges. You spin it off real quick, so you lose minimal refrigerant. Okay, through the pressure transducer, you should, between the red wire and black wire, you should always have 5 volts DC. And then between the black and green, you should have a 0.5 volt to 4.5 volts DC, depending on what the pressure is. And there is a chart in the installation manual. This is for your low pressure transducer. You should be, if you have 3.75 volts DC, your pressure, suction pressure should be 244 pounds. Okay, you got to hook up a set of gauges to do this. So you should be looking at your suction pressure and measuring your voltage. Okay, so if you have that voltage, it should correlate to the right pressure. If you're measuring 3.75 volts DC and you got, I don't know, 300 pounds, you probably have a bad pressure transducer. One other thing, when you're working on all this electronic stuff, you need to get yourself a set of probes, electronic probes, that are little fine ones, because the ones they give you with the meter are too fat. You can't backpick these Molex plugs. Or go to Staples and get yourself a box of paper clips. And then you just open it up, stick the paper clips in there, and then it'll work. I did it for years.
I'm ready.
Okay.
Let's hold on.
Then we have a different chart for high pressure, because at 3.75 you're going to be at 528 pounds. So that's how you check your transducers. If you have thermistors that are problems, in that, I already told you, in that at your fingertips chart on my RUUD, you can print that off, and it gives you whatever the resistance reading should be in 1 degree increments. So it's a really good chart, and that's what it looks like. So it'll go from 0 degrees to 130 degrees in 1 degree increments. And that'll work on any 10K resistor, anybody's. So we've got compressor over temperature protection, meaning there's a sensor on the discharge line of the compressor. If it gets over 265 degrees for more than 30 seconds, it's going to display a fault code, and the compressor RPM is going to start reducing, slowing down until we can get that discharge temperature below 200 degrees. Once it gets below 200 degrees, then it will try to come back up to whatever the commanded speed is. And if it can stay below 200, it'll keep running. If it doesn't, it's going to slow back down again. All of the inverter product will work that way. Okay? Like I keep saying, those are really expensive compressors, and they have a lot of stuff on them to protect them. Flame sense troubleshooting. Anybody put any 962 furnaces in, had flame sense during cooling? A014F and A127F fault codes? Anybody had that?
47.
Well, shit, we ain't talking about it then.
47 code pop up?
A what?
You said 47 code?
No, 127, AO127_F and AO14_F, right? Okay, what that is those are fault codes. It sensed a flame signal when there was no call for heat, and the gas valve was not open. Okay? So it's a false signal. But in some time, most of the time it's not a big issue. Sometimes it will, if it does it so many times within a call for cooling or a call for heating or cooling, it will put you into a 1 hour lockout. And that's when the homeowner will see it. Okay, PWM signals, because this is a constant torque blower motor on these furnaces and air handlers. You need to be able to measure the PWM signal to find out if the motor's communicating. So, by measuring the PWM signal, it'll kind of give us an idea if you're running at 10% torque or 100% torque. So, if you're measuring between terminal 1 and common on the blue wire, you should have between 1 and 24 volts DC. If you measure between number 3 and common, you should have between 1 and 24 volts DC. These two wires do different things. The number 3 wire, the red one, that's your PWM signal. That's the signal that the board is sending to the motor to tell it how much torque it needs to exert to get the CFM that the outdoor unit needs or the furnace needs. That blue wire coming back, FB, that's feedback, is the motor responding back to the board saying, we're turning at this RPM. So when we were looking at that app and it showed you the motor RPM on the indoor blower, that's where that comes from. Okay, you should also have on terminal 4, between terminal 4 and common, you should always have 24 volts DC. Okay, that's just power to the motor. This thing is set up so that if it doesn't get feedback from the motor, it's not going to give you a no heat. It's going to give you an alarm, but it's going to revert to a plain constant torque motor. And it's just going to run at a single speed. It's not going to modulate up and down. Okay, so you won't have a no heat, but it's going to send you an alert or alarm, or send the homeowner an alarm telling them they have an issue. Okay, so it will go to constant torque if you lose the PWM signal and not leave you with a no heat. And it will give you a T117_F, which will tell you that the motor RPM failure occurred. This is between L and N and L and G. Over there on the high voltage terminals on that motor, you should always have 115 volt on a furnace motor. Okay, so if you've got 115 volts on that furnace motor and you're getting a PWM signal, it should be modulating. If you're getting 115 volts of the motor and you're not getting a feedback signal, it's going to be operating, but it's going to operate as a constant torque. And air handlers are the same. Okay, the PWM signal, it's just, instead of 115 volts, you're looking for 230 volts.